Hello student, the question says the current I coming from the battery and ammeter readings are. So we have to find what is the current coming from the battery and also we have to find what is the ammeter reading. So in these kind of questions, I will explain in detail rather than try to explain very quickly. Let us look at the multiple ways to solve these kind of problems. First of all, whenever an ammeter is given, so if nothing, no resistance of ammeter is given, we will assume that ammeter has zero resistance. That means we will assume that this is an ideal ammeter. So the only role of this ammeter is to measure the current. That's it. Whatever is the current that is flowing, and it will not like do anything else in this circuit. Next, we have to know what is the goal of current in a circuit. The goal of current is generally to start from the positive plate. This is generally how we try to solve these problems. This may not be exactly true, but just think in this direction. It will help you to solve the problems. The goal of the current is to start from the positive plate and reach the negative plate. So when it wants to start from the positive plate and reach the negative plate, you might wonder why it can't go in this way. It cannot directly jump from positive to negative plate. It has to go through the wire zone. In this process, it has reached something called junction. Junction means it's a place where multiple routes are possible. Either my current can go from in this way and slowly it can travel through this and it can reach the negative plate. So it can slowly travel through this and it can reach the negative plate. This is one way. Another way is my current can come here, it can go through this and again it can reach the negative plate. Again my current can go through the bottommost one and again reach the negative plate. So basically this is a situation where these things are in parallel. Like you can see that this 4 ohm, this 4 ohm, and this 4 ohm, all the 4 ohms are in parallel to each other. So if you already know that they are parallel to each other, this explanation might be lengthy for you. So once we know that this 4 ohm, this 4 ohm, this 4 ohm are parallel to each other, we can write instead of this entire circuit R effective of this 4 ohm, this 4 ohm, and this 4 ohm. So it would be 4R by N. If resistors are in parallel and all of them are equal, their R effective would be R by N. So it would be 4 by 3 ohms. So the R effective of these three is 4 by 3 ohms. So if I redraw the circuit, I can assume instead of these three things, a 4 by 3 ohm resistor and a 4 ohm resistor and then a battery of 2 volts. From this, what is the current in the circuit? The current in the circuit is 2 divided by this entire thing is in series. So 4 plus 4 by 3. So you will basically get 6 plus 12 plus 16. So you will get the total current in the circuit is 3 by 8 amperes. So the total current, that is the main current that is flowing from the battery is 3 by 8 amperes. When 3 by 8 amperes eventually reaches here, it has 3 paths to go. And if you notice it, all three are equal resistance. Whether it goes through this path, it will meet 4 ohms. If it goes this path, it will meet 4 ohms. Whether it goes through the upward path, it will meet 4 ohms. So the current would divide equally. Through this, 1 by 8 would go. Through this, 1 by 8 would travel. Through this, 1 by 8 ampere would travel. So this is how the current would be distributed equally in all of them. So what is the resistance in the ammeter? The resistance in the reading in the ammeter would be 1 by 8 ampere and the total current would be 3 by 8. So the reading in the ammeter would be, so coming from the battery would be 3 by 8 and the ammeter reading would be 1 by 8. So the correct answer for this would be option 1. But let us explore another ways to solve the problem. Rather than doing this one way, let us see is there any other way to solve this problem. Let us assume you understood that this would be 3 by 8, but you don't know that you have to divide the current equally. So then what should I do is, I will assume the current I1 is flowing through this. I will assume a current of I1 is flowing through this. Once we assume a current of I1 is flowing through this, let us use something called Kirchhoff's loop law. What is this Kirchhoff's loop law? You start from any point. You start from any point. Let me call that point as A. You select a loop. So this is the loop I am selecting. This entire loop is the loop that I am selecting. Once we select a loop, you travel slowly in the loop. So right now, this is the point. You are traveling in the loop. If you are traveling in the direction of current, it would be positive voltage. If you are traveling opposite to the direction of current, you will take negative voltage. Like, what do you mean by that? I'll just tell you. So we are traveling down, then we met a resistor. So you will write 4 into I1 because I'm traveling in the direction of current. So slowly after traveling from the direction, then the next thing that we met is ammeter. Ammeter has zero resistance. Then, as I'm trying to again come back to A, I met the negative plate of a battery. If you meet the negative plate of a battery, you will write minus symbol. So again, I will write minus 2. And you might wonder, next time at the positive plate of a battery, should I write plus 2? You shouldn't write it. For a single battery, only one time you have to write it. So minus 2, and slowly travel, travel, travel. You met a resistor. But what is the current flowing in this resistor? In this resistor, we know the current. It is 3 by 8. Current is flowing to the left. You are also going to the left only while you are traveling. So you will write plus 3 by 8 into 4. Again, we reached the same place, right? You started from A, you again reached A, so the potential difference is 0. So this entire thing equals to 0. You might wonder what I am doing here. What is this 4 into I1? If you notice it, I am multiplying resistance with current, which will give me voltage. So we are trying to find the potential drop as I am traveling this. Just think that as you are traveling, finally we will equate it to 0 because we have again reached the same place. This is called as Kirchhoff's loop law. From this I can write 4I1 equals to 12 by 8 minus 12 by 8 plus 2. So minus 12 by 8 plus 16. So you basically get 4 by 8. Now from this we will get I1 equals to 1 by 8 ampere. So if you can find the original current as 3 by 8 ampere, you can find the individual current using Kirchhoff's loop law also. Now we will explore even more possibilities. Like we will see all the variety of methods we can use to solve this problem. So let us see one more method to solve this problem. Because if you know all the methods, depending upon the question, you can use the method that is most convenient for you. Let us assume a current I is traveling through this. A normal current I is traveling through this. We know these three are in parallel. So I can write this is 4 and this would be 2 volt. This is 4 by 3 ohm because R effective is 4 by 3. For this problem, I personally don't recommend this method, but this method would be useful for other varieties of problems. You will assume the voltage in this is V1, the voltage in this is V2. These are in series. In series, current remains same. In series, current remains same. What happens when current remains same? We can say voltage is directly proportional to resistance because V equal to IR. From this I can write V1 by V2 equals to 4 divided by 4 by 3. So V1 by V2 I can write it as 3 by 1. And what is the voltage these two are distributing? They are distributing the 2 volts. So V1 plus V2 is 2 volts. This is called as voltage method. The method I'm explaining you right now is called as voltage method. So in this voltage method, we will use the ratio and sum. So V1 by V2 is 3 by 1, V1 plus V2 is 2. If you want V1, you have to find the corresponding ratio. The corresponding ratio is 3 divided by sum of ratio 3 plus 1, 4 into total is 2. So again I will repeat corresponding ratio divided by sum of ratio into the total sum. So we will get this value as 3 by 2 volts. Similarly, voltage V2 would be equals to, we know total is 2, right? So 2 minus 3 by 2. So it would be 1 by 2 volts. Once we get V1 and V2, what can I do about this? So let us take this diagram. We got the voltage across this is 3 by 2 volts and voltage across this 4 by 3 ohm is 1 by 2 volts. Whatever is the voltage across the effective resistance in parallel, Each one also would have V2, V2 and V2 only. So that's the speciality in parallel. So each one has voltage of 1 by 8 volt, 1 by 2 volt, 1 by 2 volt, and 1 by 2 volt. Now we can find what is current in the circuit. The main current in the circuit is voltage divided by its resistance. So you will basically get 3 by 8 ampere. Similarly, if you want I1, voltage divided by resistance, 1 by 2 into divided by resistance, so 1 by 8 ampere. This method might look unnecessary and very lengthy, but this voltage method would be useful in other varieties of problems. Not, it may not be useful in this problem, because in this problem the ideal way is to quickly find the resistance. As soon as the problem is given, you will quickly find the R effective, and then we will just divide the current into equal parts and we'll quickly mark it and go. Just to explain you all the methods, I have went through this. Hope you understood how I have solved. Thank you.